Right? How are you using it?
I'm using this.
Oh.
This is because the meeting.
Ah,
Because I came over here to make.
you're using this?
No, I'm using this.
Okay.
This but on this for
Oh, okay. Okay. But is it going to pick up your sound?
No, the sound also.
Also in there?
Yeah.
Oh, okay. All right, good. You know. We'll just wait a few more minutes. Oh, downstairs?
Yeah.
Oh.
I recommend it. It'll help us.
And also Musab brought some goodies.
I'll be right back.
Musab have to switch here. This place.
Why?
This is if we switch like this.
I'll make the screen.
Yeah, we need to see this. Maybe we turn off one of the lights. Is that better?
Yeah.
All right.
You have a lot of people on Zoom.
No, I muted the microphone and the sound. And Sabina will sign in on the Zoom.
I didn't bring. You can do it? Oh, thanks.
What's up?
Yeah, so Lean-BIM-LCA for optimal green building.
Yes.
Sound is good?
That's good.
All right, so maybe we can start.
Just want to get some more people now.
Sorry?
That's fine.
Yeah. Okay. Oh, that's amazing. Thank you. Hope you came with a plan. Okay, so let's start. So it's my great pleasure to introduce Musab Maraqa, my PhD student, jointly supervised with Professor Raphael Zaks, to give his seminar, his first seminar for his, as he's preparing for his PhD proposal defense. A little bit of background about Musab. He completed his master's degree in civil engineering and construction management last year. Did a very interesting work bringing together lean construction principles with life cycle assessment. And he's extending this now even further into his PhD work. So, Musab, please.
Thanks very much, Professor Sabina, for this introduction. So today I will give a presentation about Lean-BIM-LCA for optimal green building. The agenda for this lecture is introduction, problem statement, research gap and the questions, aim and objectives, the methods and work plan, and to present something about what completed to date and what is in progress and the research completion.
אתה יוצא בסמסטר
הסמסטר הבא כרגע.
הבא שזה שישי שלך?
זה השישי שלי.
במבנים.
Everybody on Zoom, please mute.
עכשיו אנחנו פה. כאילו, זה הסמסטר דברים שאני צריך לקחת.
כן, סמסטר עמוס מאוד.
זהו, ואין שום דבר שאני יכול לקחת מהסמסטרים אחרי זה, זה רק הסמסטר הזה בתחתי.
לא, גם לא דברים האלה נפתחים אף פעם בשנה.
לא, אני אומר בשם. מה זאת אומרת?
מה זה שם?
באוניברסיטה שאנחנו ללמוד בה.
אוקיי, בוא נראה, אתה מפסיד פה הרבה קורסים, בוא נראה מה אתה יכול...
אז זהו, אז מה ראיתי?
מה אתה יכול לקחת שם?
אז ראיתי בינתיים את הדברים האלה, סויל מקניקס, זה לדעתי הנדסת קרקע, כן אותי אם אני טועה.
דומה, כן.
That's it. Yes. Mute all. Okay, good.
So lean construction refers to the application and adaptation of the underlying concepts and the principles of the Toyota production system. It includes the construction. It includes several principles, value stream mapping, flow, toll, and continuous improvement. Many researchers studied the effects of implementing lean in construction. They found that it reduces cost, time, waste, and uncertainty. It improves the workflow, planning efficiency, and construction participant satisfaction. Building information modeling is a verb or adjective phrase to describe tools, processes, and technologies that are facilitated by digital machine readable about a building, its performance, its planning, its construction, and later its operation. Lifecycle assessment, LCA, has emerged as a framework to address the environmental impacts in multiple industries. The framework for the lifecycle assessment consists of different steps like goal and scope definition, inventory analysis, and the impact assessment. Green building rating systems. The green building is healthy facilities designed and built using ecological first principles. There are 4 pillars for any green building rating system: minimization of the environmental impact, increase of the health conditions for building users, the economical returns to investors and local community, and the life cycle impact on the planning, development, and operational phases. There are different green building rating systems around the world, like leadership in energy and environmental design related to the United States, building research establishment environmental assessment method related to the United Kingdom, Green Star in Australia, and Institute for Transparency of Contracts and Environmental Compatibility Protocol in Italy, comprehensive assessment system for building environmental efficiency in Japan. Green building rating system. This table shows some similarities and differences between different green building rating systems around the world. For example, if we look for the first one for the site, we can see that in the ecological aspects and local characteristics, all the green building rating systems have the same thing. But for example, on the site hazards, Green Star and Clarion interested in recommending some studies about this, but CASB, LEED, and Etica does not take this in considerations. The same thing, for example, in the materials. Completing a life cycle assessment for the product that you use in the project is required in Green Star and Graham, but not required in LEED, Etica, or CASB. Waste in construction. Waste is one of the central concepts that Lean aims to eliminate. It represents any exhaustion of time, money, equipment, and energy, which does not bring direct value to the customer. There are, according to Lean construction, there are different types of waste in the transformation flow and the value. So the type of waste related to the transformation is the material waste, which it could be in material waste, non-optimal use of material or non-optimal use of machinery, equipment, and energy. The type related to waste related to the flow is time loss, which is, there are 2 types here in the losses, in the work flow and in the product flow. In the work flow, it includes unnecessary movement of people, unnecessary work, inefficient work, or waiting. while in the product flow, it includes space waiting, materials not being processed, or unnecessary transportation of materials. In the value, the type of waste is associated in the main product and in the byproduct. In the main product, like lack of quality or lack of intended use. In the byproduct are the harmful emissions and injuries and work-related sickness. Lean construction and green buildings. Many researchers try to study the relationship between lean construction and the green building rating system. Most of their effort focused on applying case studies for projects that are applying lean principles and they are green. So for example, Sargent et al. Studied the relation between green costs and lean saving in a residential project in Brazil. Results showed that the waste index in this project is reduced to 10.93 centimeters per meter square compared to a traditional project with 13.53 centimeters per meter square. So a reduction in material waste by approximately 20%. Also, Dixite et al. Studied the relationship between lean construction and sustainability. They mentioned that there is a strong linkage between lean construction and the green building rating systems. Both of them are concerned on resource management, waste reduction, energy minimization, and health and safety improvement. On the other hand, other studies argued that there are some contradictions between lean construction and the green building rating systems. And in sometimes attaining lead points may require investment of time and effort and money, which does not bring direct value to the customer. Also, sometimes, in order to achieve some lean principles, you need to invest more energy. For example, small batch just-in-time deliveries. Other studies try to study the relationship between lean construction and building information modeling. So Zacks et al. Developed metrics between BIM functionalities and lean principles. They found that there are 56 interactions between them, 48 out of documented evidence. Also, Maraqa et al. Studied the effects of implementing BIM and lean in improving the workflow in construction projects. They studied 18 construction projects distributed on a time scale from 2011 to 2019. They found that implementing BIM and lean improved the workflow to 8.12 compared with PowerPoint 91 in traditional project on a 10-point scale. So the problem statement in this research that in the transformation flow value theory, reduction in construction can be understood in three complementary ways. Transformation performed by workers, equipment, tools, process, which include the product flow and the process flow, and value, which is the customer's ultimate goal. In the current state of construction, the construction industry associated with numerous amount of waste. Some of these waste are tangible and visible, like material waste delivered to the landfill. On the other hand, there are a lot of hidden waste, which include process waste and their associated operation, which are associated with greenhouse gases. So currently, green building rating systems focus on environmental performance, but ideally on life cycle basis. So they focus on the material used in the construction, site and water planning, methods of recycling water, building efficiency in energy, lighting, insulation, and acoustic performance. This approach is tailored to meeting end product. However, these requirements are influenced by many process gases and improving the environmental performance. Develop a framework that measures the effects of the transformation flow value theory from 3 dimensions: transformation, flow, and value. The framework should be comprehensive and capture all the embodied greenhouse gases related to the construction activities. Introduce knowledge about the process effects of lean construction combined with BIM functionalities and life cycle assessment framework to optimize green buildings as a product. Develop a method to measure the environmental effects of different construction production systems and identify the effect of different management approaches in reducing the product and the process waste and improving the environmental performance, which in turn can reduce the effects of climate change. So the gap and research questions. Researchers focus on the green building rating systems from the transformative perspective. They focus on the embodied greenhouse gases in the materials and in the products used in the construction project and their transportation from the source to the project. However, they neglect the process and their associated operation. So they miss the impact of the waste related to the flow and value perspectives. So this research tries to fill the gap on neglecting process effects in reducing different types of waste. So this research generates many questions. The first one is, are the current rating system adequate? Second question, in what way are the current green building rating systems are inadequate in terms of reducing environmental impact? What is the effect of applying the transformation view approach alone to achieve green buildings while ignoring flow and value views? What are the best ways to overcome the gap in the current green building rating systems and to include the flow and value perspectives? What data are needed to complete a comprehensive assessment and evaluation for the construction process? And how can we collect the required data? So research method and work plan. The work plan consists of 5 main steps. The first one is problem definition, preliminary data collection, framework development, method development and testing, and the validating step. The first one is the problem definition. So I identified the research gap by extending an extensive literature review. The literature review covered 5 main fields, which building information modeling, lean construction, waste in construction, green building rating systems, and life cycle assessment. The second step is preliminary data collection and analysis to determine the effect of the flow and value perspective on the environment. In this step, I need to collect some data from local and international projects in order to evaluate 2 things. The embodied greenhouse gases related to the transformation, which mean the greenhouse gases embodied in the materials. And the second thing is to start quantifying the impact of the flow. And this is by bringing data about how much this project consumes in terms of manpower, in terms of resources like oil, gas, electricity, to run this project, and to test the relationship between the flow and the project's consumption of different resources. The third step is research method and work plan. So in this step, we need to develop a framework to measure the environmental effects from the 3 dimensions, the transformation, the flow, and value. So if we look in this figure, we can see the 3 dimensions, the flow, the transformation, and the value. Now, in the flow, there are 2 types of flow of resources and flow of locations. So the different resources in the construction project, like materials, subcontractors, information, and equipment, all these resources are flow to the different process. These construction process are the input for the different location in the project. So for example, process A represents the main structural system, which it has also different operations. Also the same thing in process B. For example, it's building the partition wall. So when we say building partition wall is the process, it has different operations like building, cutting, moving the block, marking out, insulation. So all these process will be the input for the different locations. The locations are the flow in order to achieve the finished building, which is the value. So this framework aims to capture all the different greenhouse gases in these steps during the flow of resources, in the transformation itself, and in the flow of locations, which are represented by the resources that consumed during the building. And it includes the different types of waste, like waste of waiting, of over-processing, overproduction, rework.
Hi. My name is.
We need to develop a method, so an iterative development and testing of a method or an instrument to capture all the greenhouse gases and to measure the environmental impacts related to the transformation, flow, and value. So if we look for this, we can see here the activity. Now, for each construction activity, there are many requirements you need to achieve. So the prerequisites for any activity are the space, preceding activities, material, subcontractor, equipment, and information. Now, while these prerequisites are a flow for the activity, there are different types of waste in the way, like waiting, inspection, and rework. So all these type of waste is consumed resources and releasing greenhouse gases. The last step is validating the method on a new construction project. So in this step, we need to apply the new method on a new construction project in order to quantify different things. We need to quantify the transformational effect, quantify the flow and value effects, and to measure the marginal impact for applying the transformation flow and value, and to see how much the improvement occurred due to implementing the flow and value. So research in progress. Today, an extensive literature review on green building rating systems, which cover the BIM-LCA, green building rating system, and lean construction and their interactions have been reviewed and discussed. Now, the research in progress, this table shows them some of the experiments that I started in order to measure the things related to the transformation and the value. So there are 4 experiments. The first one entitled is reducing construction and demolishing waste through lean production. And the second one is material passports. This is related to the transformation. Now, 3 and 4 are empirical assessment of the impact of BDC and lean on reducing operational waste in masonry works and evaluating the space weighting effects on generating greenhouse gases, these related to the flow. So the first one is reducing construction and demolishing waste through lean production. This research is introduced in a conference paper in the 9th International Conference on Sustainable Solid Waste Management in Greece. So the idea is to study the effect of applying centralized mixing station in the construction site. So the centralized mixing station, the idea is in the conventional way, generally the subcontractors, when they are working in the construction project, each subcontractor mixes his own materials. For example, the tiling, the plastering, the gypsum things in a separate location. So they need to deliver all the materials, all the water inside the construction site. They mix in an inefficient way. And at the end of the day, if there is surplus material, he doesn't care if he wasted it because he doesn't pay money for these materials. So the idea of the centralized mixing station is to mix in a central location in the construction project for all the subcontractors and deliver the mixed materials based on their request. So the subcontractor in different locations can send a signal for the worker be sitting in the station. The worker receives the signal as seen in this figure. Now, this signal shows different digits. Each digit represents something. For example, one of the digits represents the location that the subcontractor needs this material. The other digit represents how much the quantities of the material this subcontractor needs. Other digit represents the code of the material, like he needs mortar, he needs gypsum, he needs glue. So once the worker received the signal, he prepared the mixed material in the exact quantity required by the subcontractor, and he delivered it using the elevator to the required location. So I went to the construction site and met the project manager, the site engineer, site superintendent, in order to identify the role and the benefits for implementing the centralized mixing. So there is a lot of benefits for implementing the centralized mixing station. The first one, eliminating the non-value adding activities related to the operational waste. And this is satisfied by providing the subcontractor with the ready mixed materials. So they spend all their time in the value adding activities and not spending their time in non-value adding activities like moving materials, mixing, and all these things. 2, eliminating the non-value adding activities related to the cleaning the construction site. So in this way, you keep the construction site clean and in order and shine, because you are not making a lot of mixing inside the construction site. So now you don't need to bring workers to clean the construction site, remove all the material waste to a specific location in the floor, delivering it using the crane, bringing trucks to deliver these to the landfill and paying money to dump all these waste. Keeping the construction site clean and in order, also this helps in reduce the accidents resulting from slips and trips, which in turn improves the safety issues. Improving the mix properties and characteristics. So a worker in the mix station mix for all the subcontractors will mix according to the specific ratios specified in the codes. And this will standardize the work, which is a lean goal. Improving the mixing quality. Also, this is satisfied by avoiding mixing to different materials with different characteristics in the same container. For example, mixing mortar in the same container where you mix gypsum material, because this causes a quality problem. For example, if you mix mortar in the same container where you mix gypsum material, we know that the gypsum particles, when it absorbs the water, it squeals. So if some of the remaining gypsum stay in the mortar, when you are plaster after a time, the plaster will crack and dislocate it. Supporting control and monitoring of materials. So the presence of material in a specific location helps in identifying and recognizing the daily consumption of the material. Also, it helps in protecting the materials from weather conditions and different conditions on the construction site. The most important point is 7 point, is the last one, which is eliminating material waste. And this is satisfied by mixing the exact quantity required by the subcontractor. How I mentioned it, additionally, the subcontractor mixes the material in a random quantity. And at the end of the day, the surplus material will be wasted. So applying the centralized mixing concepts helps in delivering the right quantity to the subcontractor in the right time, which means that at the end of the day, the material waste will be close to zero. And in this way, we are achieving the pull flow against the push flow to reduce the excess materials. The second experiment is started by quantifying a transformational effect through material passports. This is related to the transformation section. So we developed something called Building Material Passport to support building deconstruction and circular economy for a commercial building, a big commercial building with around 50,000 meters square. So the idea of developing the material passport in order to test the embodied greenhouse gases in all the materials that used in that project. Also, it showed the potential for these materials for recycling and reusing waste, which in turn helps the circular economy. So the methodology for completing the material passport for the project, we got the BIM model from the construction company. We scheduled all the quantities related to the different families and types in the project. So we quantified and we got all the quantities for the materials. This material will be as an input for life cycle assessment software, which we selected Gabi in this stage. So Gabi, it helps in building the life cycle assessment process flow diagram in order to estimate the environmental effect per functional unit for the project. Now, some of the materials, their embodied greenhouse gases exist in Gabi, others are not. So we brought it from technical data sheet associated with materials or from the literature. We calculated the material waste in the building, which is actual delivered material to the construction site minus actual built. Now, the results for this is the material passport, which is presented in the 3 environmental metrics in greenhouse gases, acidification potential, and primary energy intensity. So this is the process flow diagram from Gabi software for each construction element. What is the material input, how it's transported to the construction site, the distance for the transportation, the type of the fuels used for the different transportation. This shows some of the material characteristics for the materials used in the project, like the lifespan, the density, the recycling weight, This is the mass at time 0 and the mass at time 100 in terms of ton. So we can see, for example, for the concrete materials, the mass at time 0 and at time 100 is the same because it's the lifespan for it, it's 100. However, for example, for the type of ducts, the pipes, all the other different elements, because like some of its lifespan 50 years, 40 years, this means it should be replaced twice or triple times during the building life cycle. And this graph shows us the global warming potential in terms of kilogram CO2 equivalent per functional unit. Actually, the functional unit in our project is 1 finished meter square. So we see that it's 477.5 kilogram CO2 equivalent per meter square. Now it's covered mainly the embodied greenhouse gases in the material and the transportation of the material, which cover the transformation perspective. Now, the second step, I started collecting data related in this project related to the flow, which includes the start-finish dates for each activity in order to calculate the flow. Also, I started collecting some data related to the resources they used in the project, like how much they consumed electricity, how much they consumed man-hour, in order to start evaluate what is the effect of the flow relating to the transformation perspective. The third experiment is empirical assessment of the impact of VDC and Lean on reducing operational waste in masonry works. Actually, I started this experiment during my master and I extended it recently. Now, this study covers mainly 3 different construction companies: Company A, Company B, and Company C. Company A started their Lean and BIM implementations in 2012. Company B and Company C are working in a traditional way or in the conventional way without any implementations of Lean and BIM. So Company A, they studied the worker activities by monitoring the worker activities every 5 minutes for building blocks in order to see how much of their time they spend in value-adding activities and in non-value-adding activities. The value-adding activities actually it includes building, gluing, and leveling, while the other things like moving a block, insulation, cuttings, moving between floors, cleaning are non-value-adding activities because it does not bring any value for the client. So they did an experiment in 2007, and they found that the value-adding activities was only 34.5%, while the others are non-value-adding activities. They did the experiment in 2014 after they started implementing Lean and BIM, like they implemented last planner system, value stream mapping. So they used the BIM in order to optimize the number of block rows in order to avoid cuttings, to deliver the blocks to the right location and in the right quantities before they placing the concrete slab in order to avoid the activities of moving the blocks. So the value-adding activities increased up to 63.6%. Now, what I did in 2019, I studied 2 construction projects that have the same scope, 2 residential projects with around 170 apartments, which is project P1, traditional project. And I found that the value-adding activities is still around 35.8%, which shows that the traditional management way does not have any improvement from 2007 until 2019. Now, the second project, which is project A3 that implements VDC, the value-added activities improved up to 68.4%. Now, recently, I studied a new project, which is project C1. It's a traditional project, but the difference between this project and the other 4 projects that the last projects are used gypsum block and Eton block, which has the same construction method, the gypsum and Eton block. You build all the blocks without need for columns and beams. Now, the new project, project C1, which I studied, it's concrete block. So the construction method for the concrete block requires each 4 meters to make a concrete column, and after each 10 rows, you need to make a concrete beam. So when I monitor the worker activities and I use the same research methodology in the last project, I found that 3/4 times of the workers is non-value adding activities, and only 1/4 of their time is value adding activities. And this is due to the waste associated to the construction method itself. So if we look now in this table, this table represents the value adding and the non-value adding activities in the 5 different projects. The first row shows the value adding activities, and the others are the non-value adding activities. So if we look for project C1, which the concrete block, we see that in this type of block, we need to make shuttering for the beams and columns. We need to make mixing, a lot of concrete to place all these beams and columns, steel fixing, dwelling, insulation, which does not exist in the other types, in the Eton and the gypsum. So this experiment showed that there are some types of waste related to the management approach, which we presented in the first project. And the fifth one showed that there are some types of waste related to the construction method for the product itself. Now, the last experiment is evaluating the space weighting effects on generating greenhouse gases. So when I said that the green building rating system focused on the embodied greenhouse gases in the product and they ignoring the flow and value perspective. Now, why I selected a project in the cold areas? Because in the cold areas, while you are building your construction project, you need to heat it. Because if you don't heat it, you cannot pour the concrete, you cannot do the activities. Even while you are pouring the concrete and after you finish, you need to keep the construction site heated in order the chemical reaction to take its place and to continue the reaction. So after you finish the main structural system, also you need to cover the building with temporary materials like nylon or these things in order to keep the building heating. But imagine that you are heating an open building in the cold areas without windows, without doors, it's not insulated. So how much you need to consume energy while you are waiting all these locations. So I studied a project in Astana in Kazakhstan called Abu Dhabi Plaza project. It's a mixed-use development complex, residential and commercial project with the area approximately 550,000 meters square. Now the temperature in Astana in the winter is from 30 to 50 degrees below zero. So they used a lot of heaters which run in diesel in order to keep the construction site warm. Now during the construction of the project, it was a lot of problems occurred like design changes and the client changes. So the project planned to finish in 5 years. However, the project overrun extended the project to be 9 years under construction. I met the project control manager in order to identify how much the diesel consumption per month for the project, and the numbers was very significant. They consumed more than 1,700,000 liters of diesel per month in order to heat the building, which cost around $1 million because the diesel liter in Kazakhstan is $0.6. So imagine how much we are spending money in something waste in terms of lean and in polluting the environment by burning more than 1,700,000 liters of diesel. And finally, the research contribution is to develop a new framework and method for evaluating the greenhouse gases emissions during construction phase. The research will introduce knowledge about the process effects of lean construction combined with BIM functionalities and LCA framework to operationalize cost-effective green construction methods that will lead to optimize the green building as a product. A method that shows how lean and BIM can optimize and improve green building is expected to have a significant impact on both construction management and environmental decision-making fields, and it will encourage more research studies in these disciplines. The research will demonstrate practical tools for any client or contractor to estimate the environmental measures like the greenhouse gases footprint associated with construction project during the construction phase. It will motivate governments, clients, and decision makers to apply this method by demonstrating its importance and benefits. And if successful, the proposed method will enable a green building at a lower cost relative to the conventional building, which will encourage change with the construction industry towards a green building. And thanks very much for your attention.
And so we have time for questions from the room before, and also on Zoom, we can ask people to write
Now I will
into the.
remove the mute for the participants.
Okay. So any questions from within the room? Are you all in the construction management area or general civil engineering? No, not everyone.
It's very interesting that you mentioned about how a lot of the green standards right now is really concerned about the product and not so much concerned about the waste or even the environment impact of process that generates this, that produces the product. So are you suggesting that in future green standards, there should be a section that is specifically like requirements on how it should be constructed and to measure that kind of
Exactly, to consider the process effects and not only focus on the products itself. Because the products, it's good, but also the process, how we showed, for example, in the cold areas, how much the effects of waiting and all these things like consumed powers and diesel, electricity, all these things in order to run your project, which is pollute the environment.
Do you have any idea right now of how that kind of regulation can be implemented? Because you can't just say you have to use this method to construct, because it's very complex construction project.
Exactly.
And regulation has to be a bit more universal. Do you have an idea of how?
Yeah, so until now, I'm proposing the framework that where is the type of waste. Now, the second step is to introduce the method. And this method, it could be qualitative things, for example, to put some recommendations or some like section in the green building rating systems, or it could be, for example, develop an index or different like numerical things to measure how much your project is releasing greenhouse gases.
Can you go to slide 37? I think it is. Just before your pie chart. Or before this. It's like the bar chart. This one. Or this. I think this one.
Yeah.
And we can see that the GHG emissions, the most is from the HVAC.
Yeah, it's back down.
So like I'm just wondering from just an environmental point of view is that seems like the biggest contributor.
Yeah.
Right? And if there is a way to, if this be considered like when we're building buildings, have we considered buildings that don't require HVAC? I know in Israel, even with the weather and things, this is kind of thinking about it, but I have seen novel designs of buildings that don't require any more, like a heating, air conditioning system, but they just designed in a way that, in a green way that wouldn't require this heavy burden, and therefore results like with GHG emissions would be reduced considerably.
So like your project design, for example, in the orientation or in the insulation of all these things, and then we don't need to use the HVAC system or to design the building like to make the erections and the installation of the HVAC system.
Right.
On the adaptation, can you go to the page before? Yeah. I mean, I guess that the difference between 0 and 100 years is that you have 116 in the first column, and you have 813 in the second column, and that's an enormous difference. Are you suggesting that, are you suggesting that you need to
To replace it, yeah.
7 times in 100 years?
It's actually, I think, 5 or 6 times. Like when I went to literature to see how much the life cycle for the HVAC system, I found that it's like 20 years approximately, because after 20 years, the losses will be very much. So they make rehabilitation or they replace the HVAC system.
Rehabilitation is one thing, but what you're suggesting is they completely replace.
Yeah,
So is there no way, I mean, apart from the literature, have you checked, for example, this building is now 20 years old. And to the best of my knowledge, they're not about to replace the entire HVAC system in the building.
yeah.
At best, they will clean the ducts. So I think it's probably, at least the sense is that that doesn't reflect what really happened. So, and then because it's 813 out of a total of,
116.
yeah,
Yeah, so maybe the rehabilitation does not mean in recipe that they need to remove all the old systems and make the new system.
exactly. By the same token, you wouldn't expect that they're replacing the entire firefighting system or sprinkler system. I think you need to consider that again.
Yeah.
Also, a question here about why you chose 100 and not something on a shorter scale.
The building is designed to service for, like, the design for the building is designed to service for 100 years. So it's assumed that after 100, like at year 101, the building will be demolished.
Else, the kind of in the same line of the HVAC is that I would take an assumption that throughout this 100-year, the entire system will stay the same. That's kind of the question is that.
Yeah, actually, I don't have experience exactly like when they need to replace all the system. So like this, maybe it was like as an assumption, but I think, yeah, it should be reviewed. For example, maybe I think 50 years, something may be reasonable.
I have a question related to the same example. So you talked about the embodied carbon in the materials, and then you also talked about looking at flow effects from this particular project. How are you going to, like, this doesn't reflect the flow effects, but you are going to do some additional data collection. Tell us about how you're going to do that.
Yeah, so this showed like how Sabrina mentioned that transformational effect, how much the embodied greenhouse gases in the materials and the transportation of the material from the source to the project. Now, the second step is started by collecting some data related to the flow, which means we need to calculate like the flow in the project by calculating all the start finish dates for each activities, and we can calculate the construction flow index, for example, as a measure for the flow. On the same time, we can measure how much the project consumed different types of resources, how much it consumed electricity, how much it consumed different types of, for example, diesel or oil, how much it consumed in terms of manpower. Now, in this way, we can identify or we can build some correlation between the flow index for this project and how much it consumed in terms of different resources.
Just one comment. And you said it yourself, because the construction method is very influential in this thing. So whatever framework you develop, it seems that has to be tailored to the specific construction method and have a framework that can use it.
Yeah. Like, yeah, as a framework, the framework, like it will introduce a knowledge how for the green building rating systems, how to think about the process itself and the operations. Because like generally in the green building rating system, they only concern about the product, like use this instead of this because the embodied in this is less, but they don't consider the process. So the aim of the framework is to introduce the knowledge and to make the people from the green building rating systems and from these to start think about the process and operational effects. Now, after that, maybe they can make like complete a comprehensive life cycle assessment to evaluate the embodied in the product and evaluate the greenhouse gases in the process, and then decide what method should use.
There's a question online.
Sabrina, can I have a question, please?
Yeah,
Musab, thank you very much for your presentation. It's nice done. A few comments, if you let me do this, about the terminology and some classification of the building materials, because you are touching the topics which are very familiar for me and for my colleagues dealing with building materials and technology. Can you please look at this slide, which is on the screen? What do you mean by layers? Can you please explain what do you mean?
yeah. Like the layers here is like if we make, for example, a section in the building. So then we have, for example, the concrete columns and walls, the concrete slab. On top of the slab, there is the tiles. So this is what I meant by layers.
But this is not a layer. Please check the terminology. This is not a layer. I would like to check it. Now, can you please open slide number 28?
Yeah.
Yes, I'm speaking about number 5 item, which is improving the mix quality. What do you exactly mean by mixing mortar in the same container? What kind of materials do you mean mixed there?
Yeah, so for example, sometimes they use some types of material like spechtel, which is they use gypsum in the spechtel. So the subcontractor makes it in a container in that location. Now, maybe he will finish his work and left for other location. So the mortar subcontractor for plastering or for other issues, he used the same container that used from a previous subcontractor. So if some of the materials is left in the container, like some types of the gypsum stay in the container, and he mixed the mortar, then the remaining gypsum particles will cause a problem for the plastering or for the mortar that mixed in the same container.
I understand. So you would like to bring the example of the so-called pathology, which is completely forbidden by the standards, mixing gypsum-based and cement-based materials. I understand. But this is a kind of pathology. It's completely forbidden. It's not improving the mix quality. It's a violation. So please...
like preventing maybe preventing equality problems.
Okay.
Yeah. So I think, yeah, instead of improving the mix quality, preventing the problems, equality problems.
This particular example belongs to the violation of the standard, but maybe you can bring some more examples illustrating the improvement of the quality, and this is okay. But my comment is just about the example you are bringing.
Yeah,
now
I think the point number 4, which is improving the properties and characteristics, because generally the workers mixed in a random way. Like they don't care about the standards and ratios. How should he, for example, mix water with cement? So they put the water in a random way. But now if there is like third party, the worker related to the general contractor, and he mixed for all the subcontractors according to the specific ratios, this I think will improve the properties and characteristics.
Okay, I understand. Now, can you please open slide number 30? Yeah, what do you mean by B200, B300, B400, B500? What is this?
This is the types of concrete like B200, B300 that used in the project. The strength is like B200, 20 megapascal.
Maybe you mean the Israeli standard classification?
Yeah. Like when they said
Musab, we don't have this grade. We have B20, B25, B30, B40, B50, and the last grade in our local standard is B60. So please check it and correct.
Yeah.
By the way, in one of the following slides, you are using the correct terminology based on the European standard. And the classification of the grades starts with C, which is concrete.
Yeah, I understand. I think
Yeah, please check it, because this is inaccurate designation, so please correct it. And last question, what is concrete bricks? It's the part of the next slide, 31. What does it mean, concrete bricks? This is in the left part of the slide in the middle.
Related to the concrete block.
Concrete blocks. You are speaking about concrete blocks for masonry, perhaps.
Exactly, but like in the life cycle, in the database for Gavi, they call it concrete bricks. So I selected it because I don't find exactly concrete blocks, so I selected concrete bricks.
I see. So it's a part of the Gavi. I see.
Yeah.
But the correct terminology is a little bit different. Okay, nice. I understand. Thank you very much. But just a comment, a general comment.
Yeah.
About your conclusions. One of your conclusions, I think the last one, number 6. Can you please open the slide with the conclusion? Yes, if successful. Do you mean that success is measured by ability to prepare some guidelines or recommendations for designers, for contractors, for quality inspectors? If yes, it would be a very, very good result of your thesis, very good impact. Do you mean to prepare in the end of your work some guidelines or recommendations?
Yeah, exactly. Like if successful, which means that the method that show how much the improvement occurs you to implementing the flow and or to consider the flow and value dimensions and perspectives, then it will like give some recommendations for these, the green buildings, the municipalities, all the different stakeholders which concern about the green buildings.
Okay, thank you very much, Musab.
Thanks for your comments.
Well done. Mm-hmm.
Are there any other questions? Okay, good work, Musab. A lot of goodies to share.
Thanks very much for your coming and your participating, and we are welcome to next week.
Thank you very much, Jeff. Thank you, Jeff.
Musab, wish you all the best, man. Great work.
Thanks, Saeed.
Take care. Bye bye.